cooling systems. Today's internal combustion engines generate a tremendous amount of heat. This heat is created when the air-fuel mixture is ignited and expands inside the engine combustion chamber. Metal temperatures around the combustion chamber can run as high as 1000 degrees Fahrenheit, equivalent to 537.7 degrees Celsius. To prevent the overheating of cylinder walls, pistons, valves, and other engine parts, it is necessary to dispose of this heat. Liquid-cooled system. By far, the most popular and efficient method of engine cooling is by the liquid-cooled system. In this system, heat is removed from around the combustion chambers by a heat-absorbing liquid, or coolant, circulating inside the engine. This liquid is pumped through the engine, and, after absorbing the heat of combustion, flows into the radiator, where the heat is transferred to the atmosphere. The cooled liquid is then returned to the engine, to repeat the cycle. These systems are designed to keep engine temperatures within a range in which they provide peak performance. The technical definition of a thermostat is a temperature-responsive, coolant flow control valve. The engine's thermostat controls the temperature and amount of coolant entering the radiator. While the engine is cold, the thermostat remains closed. A bypass circuit allows coolant to circulate only inside the engine. This allows the engine to warm up uniformly and eliminates hot spots. When the coolant reaches the opening temperature of the thermostat begins to open and allows the flow of coolant to the radiator. The hotter the coolant gets, the more the thermostat opens, allowing more coolant to flow through the radiator. Once the coolant has passed through the radiator and has given up its heat, it re-enters the water pump. Here it is pushed through the passages surrounding the combustion chambers again, to pick up heat and start the cycle. The thermostat controls the minimum operating temperature of the engine. The maximum operating temperature is controlled by the amount of heat being produced by the engine at the time, and the cooling system's ability to dissipate the heat. The thermostat also maintains proper engine temperatures to keep the emission control systems working properly. Many vehicles failed the emissions test because they are operating at too low temperature. Coolant. Coolant is actually a mixture of water and ethylene glycol-based antifreeze, or coolant. Water alone has a boiling point of 212 degrees Fahrenheit, or 100 degrees Celsius, and a freezing point of 32 degrees Fahrenheit, or 0 degrees Celsius, at sea level. A mixture of 67% antifreeze and 33% water will raise the boiling point of the mixture to 235 degrees Fahrenheit, or 113 degrees Celsius, and lower the freezing point to -92 degrees Fahrenheit, or -69 degrees Celsius. The antifreeze concentration must always be a minimum of 44%, all year, and in all climates. If the percentage is lower than 44%, engine parts may be eroded by cavitation, and cooling system components may be severely damaged by corrosion. Never fill the system with 100% ethylene glycol. This can cause extreme engine heat, which can cause serious engine damage. Also, the use of propylene glycol, or mixtures of propylene glycol and ethylene glycol antifreeze, is not typically recommended by automotive manufacturers. Check the service manual before using these chemicals. Most cooling systems today use an expansion or recovery tank. Cooling systems with expansion tanks are called closed cooling systems. They are designed to catch and hold any coolant that passes through the pressure cap when the engine is hot. As the engine warms up, the coolant expands. The coolant passes to an expansion tank. When the engine is shut down, the coolant begins to shrink, Eventually, the vacuum spring inside the pressure cap opens, and the coolant in the expansion tank is drawn back into the cooling system.